Next, we discuss another problem. Prove that in n Bernoulli trials with probability of failure is q. The probability of Admos k success. The probability of Admos k success is integration 0 to q x to the power n minus k minus 1 into 1 minus x whole to the power k dx by 0 to 1 x to the power n minus k minus 1 1 minus x whole to the power k dx. So probability of Admos k success is this. We prove this. Prove. Given that probability of failure is q, so probability of success is probability of success is p, where p is 1 minus q. Okay, so probability of Admos k success means p of a0 plus p of a1 plus dot up to a to a k. So p of a0 plus p of a1, these are mutually exclusive events, up to p of a k. P of a0 means nc0 p to the power 0 q to the power n minus 0. P of a k a1 means nc1 p1 q to the power n minus 1 plus dot dot nck p to the power k q to the power n minus k. That is summation of I equal to 0 to k nci p to the power I q to the power n minus I. In the given question, we prove that this equal to integration 0 to q x to the power n minus k minus 1 1 minus x whole to the power k dx by 0 to 1 x to the power n minus k minus 1 1 minus x whole to the power k dx. We prove that this equal to this. Okay, let ik equal to let ik equal to this. Ik equal to 0 to q x to the power n minus k minus 1 1 minus x whole to the power k dx by 0 to 1 x to the power n minus k minus 1 1 minus x whole to the power k dx equal to 0 to q to the power n minus k minus 1 1 minus x whole to the power k dx by 0 to 1 x to the power n minus k minus 1 this 1 minus x whole to the power k plus 1 minus 1 k means k plus 1 minus 1 dx. This is the beta gamma function. This is the beta n minus k comma k plus 1. This is beta of n minus k plus 1 of integration 0 to q x to the power n minus k minus 1 1 minus x whole to the power k dx, where this beta mn equal to 0 to 1 x to the power m minus 1 1 minus x whole to the power n minus 1 dx. This is beta gamma function. Here m is n minus k and n is k plus 1. So 1 by beta n minus k comma k plus 1 equal to into integration 0 to x to the power n minus k minus 1 1 minus x to the power k dx. Also beta mn equal to beta mn equal to gamma n by gamma m plus n. This is the gamma function relation between gamma function and beta function. Beta mn equal to gamma m into gamma n by gamma m plus 1 m plus n. So this is gamma n plus 1 by gamma n minus k into gamma k plus 1. Integration this terms, integration this 0 to q x to the power n minus k minus 1 minus x whole to the power k dx. Also gamma n plus 1 equal to n factorial if n is natural number. If n is natural number. So this is n factorial. This is n minus k minus 1 plus 1. So this is n minus k minus 1 factorial. And this is k factorial. Integration these terms 0 to q x to the power n minus k minus 1 minus x whole to the power k dx. We break it by integration of by parts. We get n factorial by n minus k minus 1 factorial by k factorial. Integration of by parts. This is the first function, this is the second function. So integration of by parts we get 1 minus x whole to the power k by x to the power n minus k by n minus k 0 to q plus k by n minus k 0 to q 1 minus x to the power k minus 1 x to the power n minus k dx. Putting these values we get n factorial n minus k minus 1 factorial k into k factorial n minus k 1 minus q to the power k to the power n minus k plus k by n minus k 0 to q x to the power n minus k 1 minus x to the power k minus 1 dx. N minus k minus 1 factorial into n minus k equal to n minus k factorial. N minus k minus 1 factorial into n minus k equal to n minus k factorial. Similarly, n minus here n minus k minus 1 factorial into n minus k equal to n minus k factorial. So in the next step n factorial n minus k factorial p to the power k q to the power n minus k by plus n factorial n minus k factorial k minus 1 factorial 0 to q in x to the power n minus k 1 minus x to the power n minus k minus 1 dx. X to the power n minus k 1 minus x to the power k minus 1 dx. This term is I k minus 1 since this is I k. This is I k. Since this is I k, this one. This is also I k. This is also I k. So we replace k by k minus 1. We get this is I k minus 1. So in the next line n factorial n minus k factorial p to the power q to the power n minus k plus I k minus 1 by 2 okay. So this is also I k, imply I k minus I k minus 1 equal to n factorial by n minus k factorial into k factorial p to the power k q to the power n minus k. Let us take summation both sides. We get I equal to let us take summation I equal to 1 to k both sides. Let us take summation both sides from I equal to 1 to k I minus I and summation I equal to 1 to k in factorial I n minus I factorial p to the power I p to the power n minus I. Summation of I minus I minus 1 equal to I1 minus I2 plus I2 minus I3 plus dot dot IK minus 1 equal to 1 to k NCI e to the power I q to the power n minus I. These terms are cancelled. These terms are cancelled. So this is I0. I1 minus I0. If we put I equal to 1, then this is I1 minus I0. If we put I2 minus I1, I2 minus I1, these terms cancel. So we get IK minus I0 equal to 1 to k NCI p to the power I q to the power n minus I. This is number 3. From 2, this is from 2. From 2, I0 is replace k by 0. So from 2, I0 is n factorial n minus 1 factorial 0 factorial 0 to q x to the power n minus 1 dx. This is after calculation. This is q to the power n. Q to the power n means nc0 p to the power 0 q to the power n minus 0. So from 3 we get IK equal to I0 plus I equal to 1 to k NCI p to the power I q to the power n minus I. Here I0 is NC0 p to the power 0 q to the power n minus 0 plus I1 to k NCI p to the power I to the power n minus I. That means I equal to 0 to k NCI p to the power I e to the power n minus I. So here IK is this 5. From 5 we get IK is this, and from 1 we see that IK is this. So from 1 and 5 we get summation I equal to 0 to k NCI p to the power I q to the power n minus I equal to integration of 0 to q x to the power n. This is integration of 0 to q x to the power n minus k minus 1 minus k x equal to the power dx by 0 to 1 x to the power n minus k minus 1 minus k equal to the power k dx. So probability of at most case success is this equal to this. This is the required result. So proved. Okay.